Hi, and welcome to the next mini lecture in the Senior Maths B Professional Development modules. This week we've got two small lectures for you. This first one from me is only really a brief one, just to talk about some of the current issues that are facing participation and teaching in Senior Maths. Also this week Phil's going to be preparing one about the general objectives of teaching the Maths B. So in this small lecture, I just want to cover a couple of things. Declining participation, issues related to gender and participation in mathematics, Indigenous learning in mathematics, differentiation, guided, directed and explicit instruction, and ways of integrating the mathematical processes. This will be a brief discussion, and I'm only going to offer a few points to try and help you to think and reflect on some of these issues. The first one is declining participation, and this really is the biggest issue that's facing mathematics in Australia, not just Queensland. We know that across the state that fewer kids are taking advanced mathematics, and many students take a course which is lower than what they're capable of. So for many kids who should or could be doing Maths C, they do Maths B. And for kids who could or should be doing Maths B, they do Maths A. And for kids who could do Maths A, a lot of them do pre-vocational or something like that. I think this trend will continue when the Australian curriculum comes along, where we've got the 4 options, but it's also evident across the states. When we've asked students why they take a lower level of maths or why they don't take maths at all, one of the reasons they say is they just don't like maths. And we've talked about that previously. But a lot of them say they don't think they need it for later study. And certainly in Queensland, this is not true. For those who are going to university, there's very few courses where they can participate without any mathematics at all. Courses like primary school teaching used to accept students without maths and science, whereas now mathematics is a prerequisite for primary school teaching. So it's important that the kids understand that they do need some maths if they want to go and do further study at university. Some students say they drop to a lower maths because they want to maximise their OP. And they think by getting a easier subject, their OPs, the chance of getting a higher OP are increased. And again, that's something for schools to talk to students about, and the way the OP system works. And the other thing, of course, they say is there's other more attractive options, and some of them would choose to do physical education or drama or one of the sciences or language or something that they just find much more interesting than mathematics. So I think it's behoving on us to first of all help the students understand the importance of maths to their career, but also to go out of our way to make it interesting and relevant and exciting for them to participate in. The consequences for them not participating can be really serious, and often they don't appreciate that at the time. Another issue we face still in Australia in mathematics is related to gender. Now, for many, many years, the number of girls participating and achieving in senior maths classes was lower than that of boys. However, we know now that the results and the participation of girls and boys at senior levels of school maths is getting close to being the same. However, we still notice that in university, there's very few girls, or at least relatively speaking, there's a lot less girls who study mathematical fields like engineering and physics and mathematics. And so somewhere along the line during their school mathematics, they decide they can do quite well, but they don't want to do any more once they leave school. So it's an important question to think about. How can we get through to the girls in our senior mathematics courses at school to encourage them to pursue some of those careers that involve mathematics? Certainly they have a lot more options open to them, but they just don't seem to choose them. Another thing we know is that Aboriginal and Torres Strait Islander students do not participate in high numbers at all in senior mathematics. And we also know that there's no cognitive reason why they can't participate and do well. We also know that there's compounding factors, as many of you will understand from the schools you work in, of remoteness. So what are the reasons why some of our Aboriginal and Torres Strait Islander students don't take senior maths? And how can we encourage them to take it and be involved more and therefore achieve? Often the key is finding different ways for them to access the mathematics. and that's a whole nother lecture, but if we can just take a slightly different task to access it or get involved with it, then we often find that our Aboriginal and Torres Strait Islander students actually have more advanced mathematical skills in some areas than the other students, and this may help them to engage with it more. One of the other issues I really want to just briefly talk about is differentiation, and I'm not talking about the calculus type, but one of the things we find with senior maths is often the material is taught straight down the middle. And yet we know in any class, whether it's a senior maths class or any other maths class or other class, there's a whole range of abilities and interest levels and personalities. And so we need to cater for all those different sorts. We can't just aim straight down the middle. We can't just choose the topic that we're interested in or the context we're interested in. We need to find ways to engage the kids and differentiating so all the kids have access at the start, and then they can find achievement and understanding through the activities. This means we have a variety of activities and contexts and tasks. There's the different solution pathways, and that it makes it accessible for all. Another thing that happens in senior maths particularly is we have pressures of time and tradition and assessment. And these things can mean that we narrow the pedagogy down to a fairly narrow, directed sort of instruction. Now, like I've said many times, there's a place for narrow, directed instruction towards a particular topic of understanding. But that sort of instrumental knowledge is not enough to cover what's required in the Maths B syllabus. So we need to use a range of pedagogies, and we need to use things that enable the kids to access the material in meaningful ways. And this will mean using a variety of approaches for teaching and a variety of tasks. So sometimes we'll need guided instruction, sometimes we'll need directed instruction, sometimes we need explicit instruction. But none of those on their own will be enough. Also, another thing we find is it becomes difficult to integrate the mathematical processes when we feel the burden to pursue the mathematical content. Now, the curriculum at this level includes knowledge and procedures, but equally it includes modelling and problem solving and communication and justification. And we need to make sure that we include all these parts. Phil's going to talk about these things in the other lecture this week. But it's important that we use appropriate pedagogies to teach these things. Sometimes we can really emphasise knowledge and procedures at the expense of the others. And what we can also do is teach modelling and problem solving, for example, as another form of knowledge and procedure. So the kids actually never engage in modelling and problem solving, they just learn the procedures around how to do it. Of course, the time pressure is the thing that can make this difficult.